So everyone has come? Okay. So good morning everyone. Welcome to this 2 days workshop training program on GIS remote sensing in water resource sector. I am Ayantika Ganguly. I will be your coordinator for the next 2 sessions. I would just like to briefly introduce myself. I am Ayantika Ganguly. I am currently working as a research associate in SAIARD and also pursuing PhD in hydrology as well. Before going into our session, I would just like to have a brief introduction about yourself as well. If you just kindly introduce yourself. মাইকটা আছে অডিয়েন্সদের মাইকটা
Sharma, Assistant Executive Engineer, Tamulpur Water Resources Subdivision, Tamulpur.
I am Sagnik Pal. I am posted as a Assistant Executive Engineer in SAIARD.
I am Aditya Akas, Assistant Executive Engineer, Brahmaputra Board.
Hello, good morning to everyone. Myself Gautam Kumar Bhattacharjee. I am Assistant Executive Engineer. I am working in the GIS and Remote Sensing Cell of Brahmaputra Board at the headquarters. Thank you.
Good morning. Myself Sri Dipankar. I am working as a MIS specialist in area. Basically, I am looking after mainly IT related works in our office. Thank you.
Good morning. My name is Siripunja Deka. I'm Senior Civil Engineering. Area Society is a government of Assam autonomous body. Basically, we are currently implementing one project that is called SWIFT. This is a fishery-based project. We basically try to restore and conservation of wetland of Assam.
Good morning. I am Assistant Engineer in Kamrup Water Resource Division.
Dhorni Dhordeka, Junior Engineer, Water Resource Division, Tamilpur.
Good morning, ma'am. I am Satyendra Padgiri, Assistant Executive Engineer, Masalpur WR Subdivision.
Good morning, everyone. My name is Julmoni Reka. I am working as a young professional, Brahmaputra Board headquarters. Good morning to all respected officials present here. Myself, Jumoni Borwa, currently working as a young professional, GIS and Remote Sensing Cell of Brahmaputra Board.
Good morning to everyone present here. I am Aditya Sharma from Water Resources Division. Thank you.
Good morning, everyone. I am myself, Dr. Kaushik Bora from Area Society as an Assistant Engineer. So we are working in the SWIFT project. Recently, it's just done. Okay.
Good morning. I am Sandan Kolita from Nalbari Water Resource Division.
Good morning, everyone. My name is Ankur Agrawal. I am a Junior Engineer in Brahmaputra Board. Currently, I am posted in Siliguri Subdivision, West Bengal.
Good morning, everyone. My name is Rahul Nama, Junior Engineer, currently posted in Agartala Subdivision, Tripura.
Good morning, everyone. I am Ajay Vishwakarma, working as a Junior Engineer in Brahmaputra Board, and currently I am posted at Gangtok Division.
Good morning, everyone. My name is Jonesh Kumar. I am posted at Brahmaputra Board, Guwahati Division, working as a Junior Engineer.
Good morning to all. Prashant Kumar Singh, working as Junior Engineer in Brahmaputra Board.
বলছি মাইকে না একটু প্রবলেম হচ্ছে, একটু দেখবে।
হ্যালো হ্যালো
ওকে, হয়ে গেছে হয়ে গেছে।
হ্যালো
Hello. I am Lipan Hang Dongoy, Water Resource Department Junior Engineer, Government of Nagaland. Good morning, everyone.
Good morning, everyone. My name is Hitokali, and currently I'm working as junior engineer under Water Resource Department, Kohima, Nagaland.
Okay, so thank you everyone for your brief introduction. So our today's session is Introduction to Basics of Remote Sensing and GIS. So before going into that session, I would just like to know that how many of you know what is remote sensing and GIS and the basic concept, and do you know anything or what comes to mind when you hear remote sensing and GIS? Anyone, if you want to say anything, like what comes to mind first when you are hearing remote sensing and GIS? Hmm. Yes, that is true. Any some of you other than that? Okay, so that's right. Basically, the concept of remote sensing is sensing something remotely. So what that means, it is the process of getting information about an object without touching that object. In simpler terms, if I want to get the information about how many people in this room right now, I don't need to touch all of you to get that information. I can just see and count that how many people are there. This is one step. Other than that, what I can do, I can take my phone. Suppose I am not here, I am in other room and I want to know that how many people are in this room attending this program. So what I can do, I can tell someone to take a picture of you and then send it to me. From there, I can count that how many people are there in this room today. So this is basically the process of remote sensing when we are doing this to the Earth's surface. So we want to get information about our Earth's surface, but it is not possible from our end to touch everything. Like if I want to know something, that what is the height of a mountain, I can't touch that. So then here comes the process of remote sensing. What is remote sensing? Remote sensing is the science and art of acquiring information about Earth's surface without making physical contact. Now we are not making any physical contact. So how we are getting the information? By the mediums of satellites, drones and airborne crafts. Okay, that is our medium through which we are getting our information, and the process is remote sensing. This is clear to everyone, that what is remote sensing? Okay. So, now coming to the process of remote sensing, there are 7 stages. First, what is the first stage? Energy source or illumination. So before, when we are trying to get knowledge about something, we need the energy source. So sun is the primary energy source. Sun provides the energy from where we get the information. So the first step is sun is the primary source of energy that provides electromagnetic radiation, and that radiation comes to our earth, travels through atmosphere, sometimes is scattered or it absorbed or transmitted. That is our second part. Third part is interaction with the target. Now whenever the radiation is interacting with anything like rivers or mountains, it gets transmitted or reflected. Now that reflection or transmission is being recorded by the sensor. That is our step 4. Now the sensor is fitted in the satellite or aircraft that I have said earlier. The sensor is fitted in the satellite or aircraft where the information is getting captured. Now the information that has been captured in the satellite, that has been transmitted and received in the ground station. There are different ground stations which captures the data that has been captured by the satellite. So in the stage 5, the recorded data is transmitted to a ground station, received and processed into usable digital data. The stage 5 is the most important part of remote sensing process. Here we are getting the data, the digital data that we are using. As a user, we are using from the satellite. The stage 6 is interpretation and analysis. This is the part what we are doing. Basically what as GIS engineer or GIS analyst, what we do is the process data is interpreted and analyzed to extract meaningful information. And then the part 7 is application part. In agriculture sector, disaster management, urban planning or flood monitoring, we use the data, and in our cases the water source is main for this session. So to integrate all the 7 steps, first is the sun. Sun is illuminating the object, and then the object is refracting or scattering, and that scattered or refraction has been stored in has been captured by satellite, and then the information that has been captured by satellite comes to the ground stations where it has been processed and transformed in digital data that we will be using as GIS engineer or GIS analyst. That is the digital data, and then by using the digital data we will analyze and process. That data will be applied in different sectors. So this process is clear for everyone, the 7th stage of remote sensing. Okay. Now coming to the platforms. There are 3 types of platform: space-borne platform, airborne platform and unmanned aerial platforms. Okay. So space-borne platform basically operate in higher altitude in our Earth orbit, which is satellite. It gives larger area, so it covers basically larger area and gives us information about more area in Earth. One of the examples is satellite image. Satellite image basically information that we get from space-borne platforms. Some examples are Landsat, Sentinel, MODIS. These are the some example of satellite images. Other is airborne platform. What is airborne platform? Which basically floats into our atmosphere, like troposphere or stratosphere. Here the airborne platforms are surfaced, like aircraft, helicopter. These kind of things are airborne platform. So what happens in airborne platform? As it is more lower in atmosphere, it gives us more detailed imagery of a smaller area. The resolution of the imagery that we have get from airborne platforms are more higher compared to a satellite image. Okay. And then comes the unmanned aerial platform, which is drone. Now what has been seen for drone is that it operates in more lower altitudes, so we can get more detailed imagery and the area becomes very small. So for satellite imagery, suppose this much area is covering. For aerial photo we can get this much area, and for drone we can get this much of area. So what happens is that in this much area the resolution is very low. The image that we are getting, the resolution for that is very low. But the airborne platform, that is more higher than the satellite image, and then the UAV or drone, the image that we are getting from drones, that is that resolution is very high. Okay. So if I am going to compare these 3, the coverage is more for space-borne platforms like satellite, the spatial resolution is higher for UAV, and the cost is higher for space-borne platform, airborne platform is medium, and then UAV is very low. If I am going to say about the application part, if we need detailed analysis or very specific analysis of any area, we will be use UAV like drones. If I want to get suppose I want to get a agriculture calendar, or I want to get the information about agriculture calendar or what kind of crops are going in a particular land. So in that case I won't be using satellite. I won't get anything from that. If I use drone data, I will get more information in which field what kind of crops are growing. Okay. So this is clear for everyone. Anyone have? Yes. Drone. Yes. Yes, there are things like bathymetry analysis we can take for underwater. Now coming to sensors. Sensors detect and measure the energy reflected or emitted by the objects. In the 7 stages, we have seen that the energy that has been reflected been stored in the sensor, which is in the satellite. So there are two kinds of sensor. One is passive sensor and the second is active sensor. Now what is passive sensor? Passive sensor is the sensors that are rely on natural energy from the sun or emitted by the earth. And the active sensors are emit their own energy source and measure the backscattered signal. So to explain in simpler terms, passive sensors do not have their own light to take any image. Okay, but the active sensors have their own light to take the image. In simpler terms, our phone, whenever we are trying to click a picture, we are turning on our flashlight. Okay, so that is the example of active sensor, that it has its own light. Just like that passive sensor use sunlight or earth's heat to capture the image. Some examples of passive sensors are multispectral, hyperspectral and thermal. These all sensors are used in satellite image. And active sensors, these kind of sensor work in day or night and in all weather conditions. The major limitations of passive sensor is that if the weather is not good, if it is cloudy, then the image will be fragmented. We won't get the many good information from that image. We will see cloud in satellite image. Okay, but that doesn't happen in the case of active sensor. Active sensors are radar, LiDAR and scatterometer. These kind of things have their own lights. Yes. Yes, no, it won't help us in the night. So if we try to compare these two, so we can say that in passive sensor, sun or earth energy is the main source, and also it is limited in weather conditions like cloud or rain, or in night time it can be work. Also it is have lower penetration. In active sensor, it has its own energy, own source of energy to take the image, and it's work in all weather, and the penetration is higher as well. Now through remote sensing we have get the image. Okay, with active sensor and other things, we have get the image, we have got the satellite image. Now what we will do? Now comes the GIS part. GIS basically is the tool that helps us to analyze the image that we have get from the remote sensing process. Geographical information system is a computer-based system used to capture, store, manage, analyze and visualize spatial data. So we have got a satellite image and we don't know what to do with it. Okay, so there comes GIS. It helps as a tool to visualize it. Now the components of GIS are hardware, we need a system. Software, we need a software, QGIS or ArcGIS. Data, we need data that we'll get from satellite image, or we have other data sources. People like us who will do the process. And methods, there are fewer methods that we'll use to analyze the data. So these 5 are the components of GIS. Now what is the function of GIS? Data capture. First we need to capture the data, get the data, then data manage. In one satellite image, there are many kinds of data. So first we have to manage that data. Then spatial analysis. Spatial analysis is like we are analyzing the data that we have managed. And after doing the process, we will be visualizing and mapping. So we will create a map to get the information that we have got. To visualize the map for layman, for like if layman can get the information what we have got, a layman will not know that as how to interpret a satellite image. So we are doing the part, and then we are giving him or her the information that this has come from that, and which is easier for them to interpret. And then the last part is this decision making. By seeing that one map, they can make any decisions with that. So everyone is clear what is GIS and how we are using it? Now there are two data types in GIS. Yes. QGIS, ArcGIS. QGIS is open source. For ArcGIS we need license. There are two kinds of data in GIS. One is raster data, another one is vector data. Now coming to raster data. Raster data represent the Earth's surface as a grid of cells where each cell has a value. In simpler terms, we can say that whenever we are clicking a picture, the picture consists of many pixels. Okay, and each pixel has its unique value or digital number. What we call is DN value, but digital number value that each pixel holds. So consisting of each pixel, a satellite image is making or a data is being formed, that is known as raster data. Okay. So satellite image is made of pixels. So whenever we trying to segregate what kind of data satellite image is, it is raster data because it is made of pixels. Some examples are satellite imagery, DEM, digital elevation model, land surface temperature, rainfall. These kind of data we get in raster format. Okay. The characteristics of raster data is cell-based structure. Every raster data has individual cell or pixel, and every cell has fixed size and resolution, and it is best for continuous surfaces, for elevation or temperature. And definitely the data volume for raster data is very much higher, like it takes 100 MB sometimes to 1 GB to get the full image of an area. Also it is resolution dependent, and the common formats of raster data are GeoTIFF, IMG, NetCDF. These kind of data is raster data. Now coming to vector data. Vector data represent geographic features using point, line and polygon based on coordinates. So what is vector data? So we have a image of a particular area. We have a satellite image of a particular area. From the satellite image we can get the information of water body, get the information of road, get the information of vegetation of that area. But we can only see that. Now we need to draw. If we want to draw the water bodies, like I want to draw a water body of a particular area. So what I will do, I need a tool. So that tool is vector data, where we are creating a shapefile. Shapefile is the thing when we are trying to draw anything. If you want to draw a water body or a point or any kind of road, for road we need line. Okay, these kind of things come in vector data. And the vector data always have latitude and longitude, x and y coordinate, because it always have information, locational information with it. Now vector data has three types: point, line and polygon. So if I want to take any kind of, if I want to take information about temples or water points, like water supply points or water stations in an area, I will use point, because there is one dimensional. There is only one place that has the location, and I will point that. So for that I will use point. But if I want to draw means in technical term we can say digitize in GIS. If I want to digitize a road network of an area, I will use line. I will draw with the line. Or river network. If I want to capture the course of Brahmaputra, what I will do? I will create a line and then draw the whole course using GIS. Now if I want to measure cadastral information or land information of an area, then what I will use? I will use polygon. I will create a shapefile, a polygon shapefile, and then I will digitize the parcels. Okay. So that is clear for everyone how we are using point, line and polygon? Okay. Now the key characteristics are, it is feature based. Definitely we are using points, lines and polygons to do. The data volume is very smaller because there is no pixel. We are just drawing something, so the data value, the data size, the file size that we are creating is very small compared to raster data. And also the variable scale and precision. Now the scale is different. For raster data the scale is predefined, but for vector data we are defining the scale. And the precision is up to the digitizer. If I am digitizing something, or someone with more experience at digitizing something, his digitization will be better from someone who is doing just like very novice in this field. So this is where the precision comes in the scene, that the precision will be different from person to person, it varies. Now how we use this data? We use for network and query analysis as well. So if I want to use, so for raster data and vector data, but the major difference is it that in pixels the file size are different for both data, and also the precision is different for both data. Now the common formats are shapefile, GeoJSON, KML. These are the common formats of shapefiles that we can see. Okay, so now these two kinds of data is needed, because we are getting the information from raster data, and then the information that we are drawing or digitizing, that becomes vector data. So basically it is an integrating process. The information is given by raster data, and that information has been transferred in digital format by vector data. Okay, so that this concept is clear, what is raster data and vector data and the difference between them. Okay. Yes, it can be digitized. Basically we are digitizing the things that we are seeing in the raster data, and the data that we are creating is vector. Okay, so the output is vector. Now everything has advantage and disadvantage. The disadvantage and advantages of remote sensing are, the major advantage is that it covers larger area in shorter time. Okay, we are getting information about whole India in our hands with very short time. If I want to download the satellite image of whole India, I can download it in minutes with the help of remote sensing. And it is cost effective for large scale studies, and also it provides synoptic and repetitive data. Like if I want to do a change detection, of an area, how the landscape has been changed, so I can get information about every month. Like I can download satellite image for January, I can download satellite image for February, and so to get the information, and I can do the change analysis of that area. Okay, here remote sensing is very good. Also it helps to monitoring of inaccessible areas. So there are major area where we can't go, in mountains, in other areas that we can't go, but remote sensors can go, satellite can capture that. So for that we can get the information about mountains and other areas as well with satellite image, and the process is also very easy. Multitemporal data for change detection, that has been said already, supports decision making and planning. Now the major objective of doing all this is to enhance our decision for better planning. So here remote sensing comes. Integration with GIS for powerful analysis. This is what I have been saying, that if we don't integrate remote sensing with GIS, we won't get the perfect analysis. I have the satellite image, but I am not digitizing it, I am not doing anything. So then only a GIS expert will be able to read it. When I am integrating with GIS, when I am digitizing the features and doing a layout or map, then a layman or someone who doesn't know GIS will be able to read it. Okay. Now the limitations are, it is affected by atmospheric conditions, cloud, haze, rain, these kinds of condition. If there is cloud, we can get clouds in remote sensing or like satellite images. It happens very frequently that there is cloud in satellite image. So what we can do, we always do that, we reduce the cloud cover. Okay, so there is a process where we reduce the cloud cover. So that is the thing. And other than that, the limited spatial and temporal resolution in some data. So what happens is that the major open source data that we get, the resolution is not that very low but moderate. Okay. So if we want higher resolution, we need to purchase the data. Now for everyone it is not possible to purchase. So that is a limitation. I can do higher resolution, I can get higher resolution, so I can do detailed analysis of an area. And also high initial cost for high-end data and software. That what has been said, that there is QGIS. QGIS is open source software, but in QGIS various things are missing, which can be only done in ArcGIS. Now you have to get the license. So these kinds of things. For remote sensing, for image interpretation, we use ADAS software, NV software. These kinds of software are not open source. These we need to purchase. Also, data storage and processing require high resources. That is the thing, that the images get MB to GB, various GB. If the area is larger, we can get GBs of data. Like if we are doing a change analysis, suppose we are doing a change analysis of an area from the year 2000 to 2025. So the amount of data that is going to create, that is huge for a larger study area. That is huge. So for that we need to purchase storage. So this is an limitation. Also, the accuracy depends on sensor and data quality. If we have lower resolution data, the accuracy will be lower. We won't be able to highlight or detect anything from lower resolution data. In case of higher resolution data, the accuracy will be higher. Because the data is clear, the resolution is clear, we will be easily able to notify or able to interpret the things. And for GIS, efficient data management, in GIS we can manage data very efficiently. Powerful spatial analysis. This is the major benefit of GIS is the spatial analysis is very powerful. Like I can do network analysis, I can do any other kinds of analysis to GIS using GIS. Also, the data visualization is very easy. The data. If a person doesn't know how to digitize properly, the data quality will be lower. If a person is properly skilled or equipped, the data quality will be higher. Time consuming data preparation, this is the point where that up until this time that GIS is doing digitization, we are digitizing our roads, we are digitizing our rivers, everything as well, but it takes huge time. It takes huge time and precision and also patience to digitize these kinds of things. And this is the part where now we are moving towards automation. We are trying to do auto-digitize things. Like we are trying to automatically digitize roads, we are trying to automatically digitize the rivers, and which has already been done and it is also possible to do, but not has been implemented in a major terms or major sense. But still it is take time to digitize properly. Complexity in analysis. Sometimes there is complexity in analysis which can be occurred due to the digitization purpose. Like if someone hasn't digitized anything properly, suppose a road has been digitized like this and some others have digitized a road like this. Now there is a overlap here. Now if it is not solved, then the data complexity issue can be seen. Okay. And the last is required professionals, skilled professionals. This is what I have been saying, that we need skilled professionals who know how to digitize, how to draw the things and how to analyze the data. Like if you are not skilled, you won't be able to differentiate between agricultural land or barren land. Okay, you need proper knowledge for that. So who doesn't know GIS, who won't be able to differentiate things, and then they can do that both parcels are agricultural land, but that is not true. And this comes to the previous point, the complexity in analysis occurs. Okay, so these are the advantages and limitations of remote sensing and GIS. Yes. Basically, in open source we can get Landsat and Sentinel. Now the Sentinel accuracy is higher, like spatial resolution of Sentinel is very much higher, but the data size of Sentinel is also higher. Okay, so in remote sensing, basically what we use is either we download Landsat or we download Sentinel imagery. If we need what? No, I didn't get you. Any one of we can use. Okay, but if we need detailed analysis, the high resolution is in Sentinel. We can use, we already always go for Sentinel if we need higher resolution.
Can we do the morphological simulation? Which one would be better, remote sensing and GIS?
For morphological flow stimulation, basically you need a satellite image as well, and then the stimulation part that will be carried out in GIS. Okay, maybe not in QGIS, but we will be using other kinds of models. Suppose we are using HECRAS. Okay, HECRAS or HEC-HCML. So we need to first delineate the basin area, right? We have to take that. In HECRAS we first take that what kind of lines as well. So the line that we are drawing, that is vector data, that is your vector format. So there you are using GIS.
For like hydrological model,
Yes.
SWAT or HMS, which one is better?
And now if you are using detail, if I want to basin level information.
Like for we are working wetland in Assam. So like which model will be better, SWAT or HMS?
Basically what SWAT does, it is a soil analysis. So the thing is soil and water analysis. So SWAT occurs when SWAT performs well in larger data set. Like if I want to do SWAT in a basin area, I can do. But for detailed analysis like basin area, or like I want to do like enhance the basin, like go in depth of the basin. So for that I can use HECRAS, HEC-HCML.
So
Detailed analysis.
We are working in Assam wetlands. So like in wetlands, like for hydrological model, so we want the daily rainfall data or monthly rainfall data? It will be better.
For wetlands, it's better to get daily data. And also, if you are using rainfall data, so in wetlands, in that case you can use SWAT using PET, ET, and then predict also. Evapotranspiration, transpiration. Also for prediction purpose, SWAT is also good. There is other thing. Actually, my PhD work I am using SWAT, so I am also doing in hydrology. So my work is prediction. Okay. So SWAT is also good for prediction as well. Okay. So now for our session, which is main important, is the application in water resource management. Firstly, what GIS or remote sensing is done good is watershed delineation. In this part, like first we have to delineate the watershed or sub-watershed, basins and sub-basins. This thing we can do using DEM, Digital Elevation Model. By using Digital Elevation Model, we can get the watershed, the sub-basin and basin of an area or drainage network. This thing we can get using remote sensing. Okay. And then water quality monitoring turbidity, algal bloom, sediment load and water contamination. These things also we can do using remote sensing. Like algal bloom. Suppose for algal bloom, we can use satellite image. We can use a particular band, a chlorophyll band. Okay, the chlorophyll band that we can use to get the information about algal bloom of an area. Flood mapping, flood extent mapping, risk assessment, flood plan mapping, flood plain map management, these kinds of things have been done using remote sensing GIS as well, like flood prediction, flood zonation. We have various models for that. We can use multi-criteria decision making, AHP, these kinds of model we can use. Okay, and then coming to surface water monitoring of reservoirs, lake, rivers, these kinds of things also we can do. There are various indices. In remote sensing, there is an indices called NDWI, okay, normalized difference water index. By using that, we can get the water distribution of that area, like surface water distribution, water body distribution of an area. Other than that, there is other indices also that we can use to get the change in lakes, change in rivers as well. Then now coming to groundwater potential. We can map the groundwater potential zone. We can predict also. By using remote sensing, we can predict the groundwater potential of an area, or how much groundwater has been left or how much has been taken away. These kinds of things we can do using remote sensing and GIS. Now drought assessment, drought monitoring using vegetation indices and soil moisture estimation, which has been taking that. We can predict drought, like the drought area. So like we can predict the future drought areas. We can also zone the present drought areas using the vegetation indices. We can with remote sensing we can get the vegetation health of an area, how much healthy vegetation is there, how much the vegetation is not healthy. We can get the area estimation of that as well from remote sensing, which you will learn in the next sessions and how to get that. Also the soil moisture estimation, we can get that from SWOT, to how to estimate the soil moisture as well. So that's all for application of remote sensing in water resource management. So thank you. This is all for this session, the introduction and basics of remote sensing. If anybody has any question, they can ask.
Then also like will we face problems from cloud or like face
No, that we can face, but that is very lower compared to that. Compared to that. Like radar, we are using radioactive waves for our information. In LiDAR, we are using light. Okay, and in sonar, we are using sound. So this kind of thing where the noise is lower compared to passive source, like cloud and other things as well. Yes.
Will all objects like radiate back the same amount of energy?
No. No, all objects won't radiate back the same amount of energy. This is a very good example I can give you, that in satellite imagery, I am just telling, in satellite imagery, the reflectance of barren land is higher. Okay, the land which hasn't been used. Because it hasn't been used, it hasn't any cover over its surface, so the reflectance is very higher. Whenever we are using a satellite image, we are getting like very illuminating things. Like whenever we are seeing very illuminating things, that is barren land, we know. So that kind of things. Okay, like for agricultural land, the reflectance is not that higher to barren land. Okay, for agricultural land, then we use colored or texture to get the information. So these kinds of things that. Yes. Yes, and that also we can use using the color variation. Like I have done a project where we have to see the agricultural cross using the color variation. We see in satellite image that agricultural land is red, but the shades are red are different. So by detecting the different shades of red, we have to like point which crop is happening, which crop is there. Yes. Yes. In case of mustard, it is very high illuminating. Yes. Yes, you were saying anything? Yes, but that you won't be able to get in the first glance. That you have to do the processing, and then you will get the knowledge gradually. Okay. Yes. Yes.
So some blooms are not harmless, but some are very harmless and very toxic. So it's depleted the oxygen. So for that, for public health and fishery, so what step we can take?
And recent studies that we are going, that they are identifying the. Yes. So there has been some studies where they are identifying the algal blooms which are not good. So then they are using that chlorophyll band. Like from the chlorophyll band, we can get the amount of chlorophyll is in one algal bloom and not. So by using that, whenever we are using NDVI, okay. So whenever we are using NDVI, the amount of chlorophyll is in the plants, we are getting very higher value. So that is the process in the chlorophyll band. Whenever we are using the chlorophyll band, we are getting the information about the chlorophyll distribution of a particular area. So by using that, we are calculating different kind of indices, and then we are getting the data. Okay, so that's all for the first session. Now we have a hands-on session. Yes. Yes. Yes, but pH value, it can't be detected from satellite image. For pH value, we need to test water. Water sampling test is needed, and then the pH value that you are getting, that can be represented or visualized through GIS. Okay, the distribution of pH value, or where is the pH value is higher, where is lower, that can be demonstrated and can be seen through GIS. GIS map, we can prepare a map. So here you are only using GIS. We are not using remote sensing. Yes, it is basically dependent. No, basically it depends on primary data. And also this is a good example, primary data and secondary data. All data, remote sensing data is secondary data. Okay, nothing primary. We are not doing a field survey. And also there is one thing that if we are doing LULC, land use land cover of an area, or other than that we are doing a water quality assessment of an area or vegetation quality assessment of an area, we are using first the secondary data for our benefit, that we are getting a overview of that area, and then we have done the analysis, we have created the map, and then now we are going for field. We are going for field validation because we need that, because remote sensing data, what we are doing is secondary data, na? We have to see through our eyes, is it here or not. This land, is it agricultural land or barren land, that I have seen in satellite imagery, because satellite imagery can be wrong sometimes, because we already said that there is cloud, there is other noises. So for that we always need field verification. Okay, that is also a thing. Anik, এটা হয়ে গেছে, এবার একটু হ্যান্ডস অন সেশন। তুমি গুছিয়ে নাও, তারপর না হয় আমি বলছি। আচ্ছা, সিস্টেমগুলোও তো চালাতে হবে। দাঁড়ান, আমি চালিয়ে দিচ্ছি। তুমি এটা করে নাও। So we will be starting the hands-on sessions shortly. Okay, in that room your hands-on session will be taking place. Any one of you have laptops with you? Okay, so how many of you have laptops, their own laptops? Okay. হ্যাঁ, 4 জনের ল্যাপটপ আছে ওখানে 4 জনের ল্যাপটপ আছে। না এখানে কি, হ্যাঁ সবার হয়ে গেলে দরকার নেই ল্যাপটপে। যাদের ল্যাপটপ এখানে কখন আছে, এখানে কত সিস্টেম আছে? আর ওখানে কজন আছে? না এখন তো হ্যাঁ ঠিক আছে, অসুবিধা তাহলে তো হয়ে যাবে।
আচ্ছা এটা তোমার টাইপ হয়ে গেছে না?
কি কটা বাজে রে? আচ্ছা হ্যাঁ হ্যাঁ 12:30 না?